Hey guys, welcome back to another tutorial on fuzzy sets. In this video we're going to talk about alpha set, and say if I give you a fuzzy set where every element has a degree of truth, how do you actually make a decision from it? So in fuzzy logic, values are not just between 0 to 1, true or false. They lie on a spectrum that exists between 0 to 1. So it can be 0 0.5, 0 0.6, and I had discussed this on a very first video, and I had mentioned about crisp set and fuzzy logic. But in real systems, whether it's AI models, control systems, or filtering logic, you eventually need a crisp outcome, either 0 or 1. So that's where alpha level set, also known as the alpha cut, comes in. In this particular video, I'll be showing you how to convert a fuzzy set into a crisp subset using a threshold value alpha. So earlier, the only difference was we were creating a crisp subset from a fuzzy set. We had no threshold alpha. But in this particular video, we're going to introduce alpha cuts, and we'll implement it step by step in Python using a clean structure approach, having this class right here, class alpha set, and a dunder method, which is the main method in this case. And in the main method, we have an object fs, which is of type alpha set, and we have initialized that to the class alpha set. Now upon writing this statement, we have basically invoked a default constructor, which is init dunder method, and fuzzy dictionary has now been initialized as an empty dictionary, and right here fuzzy dictionary will be of type dict, and in third brackets it will have the key, which is str, and the value, which will be float, right? Float value, float type, and the value is basically the membership value corresponding to that element, which is of string. Like, we will particularly give a, b, c as the key instead of giving numerical values right here. So in fuzzy dictionary, we have a set of keys and set of membership values. So to enter those keys and values, we call create fuzzy dictionary to enter the elements first, and then upon entering those elements, we keep adding values, that is for each element and for each membership value. So as I explained before, that we run two loops right here, one to enter the element and one to enter membership values. To enter the elements, we first check whether they already exist in the fuzzy dictionary or not, and this fuzzy dictionary exactly has a size of the number of elements that we had entered earlier, right? um, right here, and it will run through the loop, and that many times is going to tell us to enter the number of keys. So if it already exists, then it'll just ask us to enter the element again, and if it doesn't, it'll just break from the loop and goes into the next loop, which is for the membership value. And we check right here if the membership value is between 0 to 1 and the condition is fulfilled, we just enter the membership value corresponding to that element and update the fuzzy dictionary with the element membership value. And if it is all fulfilled, then we just break from the loop and we move on to the next method, which is given in the main method right here. We have in line 48 alpha, which is of type float, says enter alpha value. So at this point, we have basically entered one complete set having its element and membership value. Now when we enter an alpha value, we are basically asking, we are basically telling the program that the alpha value is this, and if the membership value is greater than equal to the alpha value that I've given, the user has given, then you calculate and you put that alpha value or the membership value into the list and call it an alpha list. So when we get the input right here from the alpha, right, when we're calculating in create fuzzy dictionary, find alpha set right here, we are basically passing alpha. We have taken the input, now the input is an alpha, we pass that input into find alpha set, and we call find alpha set, this method, and we are receiving the alpha, which is of type float, and this method, a find alpha set, is returning a list to us. So this method is responsible for taking in alpha value, which is of type float, and it will return us a list. So I have initialized alpha set, which is of type list, and initialized as an empty list right here. We run a loop through the fuzzy dictionary, and so that we have access to both key and value using the items method for that dictionary. We cannot use, right, so in so we check right here if value is greater than alpha or not, right? So in member, same right here, if membership value is greater than alpha, that means that if the membership value that we have corresponding to its element, which is the key, is greater than the alpha value or not. If it is, then you append or you add that key to that alpha set, right? So I should rename this to alpha list because that makes more sense, right? Since we are returning a list right here, it should be an alpha list, and running that loop and checks that if the membership value is greater than the or equal to the alpha value, then you just append it to that list. And after having appended to a list, now since we have alpha list as the number of keys that we have, we set it on alpha set, which is also of type list, right? So we have the original dictionary, which is fs, which is object dot fuzzy dictionary, which contains the original set, and we have the alpha set, which is basically giving us a list in third brackets, the number of keys in it, which contains the membership value greater than the alpha value. So if I just run this, right, so enter the number of elements, say 3, a 0.7, element b I give 0.2, and c, say I give 0, right? Now it's asking us to enter the alpha value. So say if I give 0.4 as the alpha value, it checks whether if 0.7 is greater than 4. If it is, add it to the list. So a has been added to the list. Next it checks if b, that is 0.2, is greater than 0.4. No, so it does not add to the list. So b is not there. And 0 is definitely equal to not equal to 0.4, so it's not in the alpha level list. So we started with a fuzzy set and applied an alpha threshold to extract a crisp subset, right? That's the core idea of an alpha cut, turning graded membership into a clear decision boundary. So keep in mind, once you apply this, you're no longer working with fuzzy data but crisp set. And if you have any questions, drop them below in the comments, and I'll see you on the next one.